In this lesson, we will learn how to handle deep images generated in Pixar's RenderMan. So let's get started. First thing we want to do is read in our beauty pass. The RenderMan outputs deep as a separate file, so the beauty pass is in an EXR. Let's grab the sphere. It's just a regular read node. View it. We can see here we have our render. And now to read in the deep data, we're going to need to use deep read. As if you remember, deep read is the only read node that can read in deep data, regardless of format. So deep read. Let's grab the corresponding, this is sphere, so grab sphere.dtext. Now what's happening here? This is an error. So we try to view it. What does it say? It says it can't read it. Now, this is a problem, of course. How are we supposed to read dtext files? Now, a quick way to check if this is a problem with NUKE or if this is a corrupt deep file is to use the PRMan render node. This is something that comes stock with NUKE. It's not something you have to install separately. Now you do need to configure it separately. And that's the key here. So everyone should have this. PRMan render, what happens? Okay, now this tells us a lot. This tells us that the dtext file is not corrupt and that it is in fact a problem with NUKE or with RenderMan in some cases. I'll explain. So what this is saying is that it can't find a library file. So if you remember from the history lesson, what I said was that RenderMan was the first rendering engine to generate deep data. So what the Foundry did is, instead of writing their own deep library to decode dtext deep files, the Foundry relies on the RenderMan Pro Server dtext library. What this means is that in order to read dtext files in NUKE, you need to have RenderMan Pro Server installed on your machine. Now what's important is you don't need to have a license. And you could also use non-commercial RenderMan if you're doing non-commercial work. You just need to have RenderMan Pro Server installed. You don't need to buy it, you don't need a license. You just need to install the installer and configure it correctly on your system. Now configuring RenderMan Pro Server is beyond the scope of this course. But what we will do is we will configure RenderMan Pro Server to work with NUKE. So if we look here, we can see there are documents in the NUKE documentation that explain reading dtext files. And what you'll need to do is you'll need to set up RenderMan Pro Server. So what this explains is that, just like in the error message, there are two environment variables that you need to be concerned with. There's rman tree and then the rman tree lib, which stands for library. It's different on Linux, Mac, and Windows. I'm on Windows, so I'm going to be showing you how to do it on Windows. So what happens is, when you install and configure RenderMan Pro Server, RenderMan Pro Server uses the rman tree environment variable to tell applications where RenderMan Pro Server is located, where it's been installed to. So what we can do is we open Control Panel. I'm on Windows 8, I should mention, but it should be similar for Windows XP and Windows 8.1. System and Security. Go to System, Advanced System Settings, And now at the bottom here, click on environment variables. So what you'll see in this list, we'll see several different RenderMan ones. We see RMan tree. So RenderMan Pro Server has been installed correctly on this machine, but NUKE can't find it. So what we need to do is, if we look at the instructions, it's talking about path. So we need the path environment variable to be configured. So we go here, we find path. Here's path, edit. So the way that this works, as you never use them, is that these different file paths are separated by semicolons. So we see here, this is the end of the list. There's a semicolon that starts a new path. So what we're going to do is add a semicolon, and then if we do percentage RMan tree, percentage, what this is an alias, and this will actually point to the RMan tree environment variable so that we don't have to type out the entire path again here. We do a backslash lib, press OK again, OK. Now, in order for this to take effect, we need to restart NUKE. Restarting NUKE. Okay. So now let's try this again. Let's create a PRMan node. And there we go. It works. We've configured RenderMan Pro Server correctly for NUKE. So now what we can do is we go back, we read in sphere, and then we do a deep read, sphere. Now it reads in. Perfect. We take a look at these, we compare. What do we notice immediately? We notice two things. First of all is that there's no beauty in the deep file, which is expected, and it's also square. Now, in this case, this is a situation where, because RenderMan deep shadow maps were normally square, in this case, a lot of pipelines will still be outputting square deep files. So in this example, I wanted to give you sort of a real-world example of a RenderMan deep file. So the first thing you want to do is look at this. It's HD 1080p, 1.0 pixel aspect ratio. It's deep reformat. So we need to reformat this deep file, change the root to match, and then it should just snap in. There we go. What we're going to do is change it to distort. There we go. Okay. So now if we wipe, what we should see is that these line up. And we can see very clearly that the reformatting has worked and they line up. So what do we do next? So we have deep data here, 2D image data here. So now we need to do deep recolor. This will inject the deep data into the normal image path. Color, depth, view it. So there we go. One thing we need to keep track of is that in this case, the alpha channel is being adjusted. It's taking the alpha channel from the deep, which we don't want. So check target input alpha. So now it matches. Something else to point out is that most pipelines, when they use EXR, they crop the bounding box automatically so that all of these extra pixels are not in the bounding box. They're empty pixels, so they're just thrown away. So what we want to do is we want to actually copy the bounding box from our beauty pass over to our deep. And this is actually a really important thing because from an efficiency standpoint, we don't want operations to be processed on every pixel, because NUKE will only process inside the bounding box. Anything outside the bounding box, NUKE will not process. So this is actually a significantly faster process than this. So what we can do is, there's a gizmo, which you can find on Nukepedia, and it's called Deep Copy Bounding Box. So here, if we plug in the image, we plug in deep, there we go. So now we compare the EXR bounding box to the deep bounding box, the recolored deep bounding box. They now match. And this is the workflow you would use in this type of a scenario. And in this scenario, basically everything that could be different is different. And I did that on purpose. Now if we can go and bring in our other cylinders. Our cylinder, and then we deep read in the cylinder detex. Just want to copy this reformat over. We want to recolor it using the same recolor settings. Copy the bounding box. And we should see bounding box ends here. Perfect. So now what we can do is use deep merge, and we can combine these two. If we look at deep merge, there we go. We've now reassembled the 3D render. So this is how you work with RenderMan.